So the first thing that we're doing today is we're stating if the function is odd, even, or neither. So 48 g of x.
Oh, was I supposed to come out?
I'm just sticking my head in on the, we're talking about AP.
Okay.
This is pre-cal, right? Yeah, so who still needs to sign in? Bella, Emma. Did you do it, Lily, on this?
But I haven't done it for the English yet.
You have for, okay.
I have.
Do you know how to do it, Bella and Emma?
Mm-hmm.
Okay. And you know how to do it? Okay, you go to My AP, so use your College Board account that you use like for the PSAT.
Okay.
And just, we can show you how to do it, but if you get in there, there's like videos and other things you can be a part of. So if you got a problem, just come see me or you can help.
Okay.
Thanks.
All right, so to determine if something is even, odd, or neither, we plug in negative x for x in the equation. So I would have negative x cubed, which is equal to what? Negative x cubed. So because this entire thing was turned opposite of the sign that it started with, this is odd. And it has to turn the whole thing opposite. We used to just say had to turn it negative, but if it started as a negative, then obviously it would have to end positive, so it has to be the opposite sign. 50 g of x equals 3 over 1 plus x squared. So plugging in negative x, I get 3 over 1 plus negative x squared. What is negative x squared? 3 over 1 plus x squared. So it becomes positive, which means it looks exactly the same as it started. The 3 is still positive, 1's still positive, and the x squared is still positive. So this one is even. (52) f of x equals x cubed plus 0.04 x squared plus 3. So plug in negative x, f of negative x equals negative x cubed plus 0.04 times negative x squared plus 3. What happens when I cube negative x? Negative x cubed. What about when I square negative x?
You get X.
Positive, so plus 0.04 x squared and then plus 3. So notice on this one, this sign is different from the first one, but this sign here stayed the same, and this one stayed the same. So this is neither. So it's not even or odd. What?
Once you get rid of the exponents,
Why?
because you
Is x cubed not x cubed?
know it is, but
When you like,
you did negative x times negative x times negative x. Isn't that negative?
Negative x cubed.
Yeah.
oh, that makes sense.
Well,
You just said exactly what you were trying to say was not occurring.
Cubing.
Negative x cubed is equal to negative x cubed.
yeah.
So why would I get rid of the exponent?
It's negative x.
So
It's cubed, so it's negative x times negative x times negative x. What does that equal?
So this one, the signs did not all change or all stay the same. So this one was neither. 54 h of x equals 1 over x. So when I plug it in, h of negative x is equal to 1 over negative x, which I can think about this as negative 1 over x like that. So what is this one? Odd. So it started positive, ended negative, so it was different. So it is odd. That's about as hard as they get in here. In calculus, they get a lot harder with determining if they're even, odd, or neither. All right, the next thing that we have to do is we are finding horizontal and vertical asymptotes of a function. That is why I handed you that clown poem, just to help you remember. Bobo, Botno, and Bosco. Not in that order, but bigger on bottom, y equals 0. Both the same, use the coefficients. Bigger on top, no there's not. Okay, if you memorize this and write this on your next test, it's 5 points. Word for word. Whole thing.
Next test, right? Not next quiz.
Correct. So you have time to learn it. Now, vertical asymptotes, the only thing that we're concerned about is the denominator. It's where the denominator is 0. Horizontal asymptotes don't just occur when the denominator is 0. They have a whole different set of things, which is why you have this poem. We'll do a few of those. 56 q of x equals x minus 1 over x. So the vertical asymptote, and these are all lines. They have to be written as an equation of a line, but where is the denominator 0? When x is what? What value for x makes the denominator 0? 0. X equals 0 is my vertical asymptote. Horizontal asymptote, I look at the highest powered term, top and bottom. So in this case, my highest powered terms are just x's. Now, what this poem means, bigger on bottom. So if the exponent of the variable on the bottom is bigger, then y equals 0. Okay? That's not what we have here. If it is bigger on top, meaning the exponent on the top is bigger than the one on the bottom, there is no horizontal asymptote, and later on you'll find out that it's something called an oblique asymptote that possibly could be occurring, but those aren't in this section. That comes later. If they are both the same, so Bosco, which is what we have, they both have an exponent of 1. We use the coefficient in front. What number is in front of both of these x's? 1. So the horizontal asymptote is at y equals 1. And that's all you have to do. I would typically recommend that you write what situation you used, Bobo, Botno, or Bosco, so that I know why you picked what you picked in case you're wrong, so that you have some work shown, because otherwise there's not really a whole lot of work, which is difficult to get partial credit if there's not. $58 q of x equals 1.5 raised to the x. Now, are there any problems with the x values in this function? Is there a denominator? No. So there's no issues. So I have no vertical asymptote, so I would just write none. Now, as far as the horizontal asymptotes on this one we can't really use Bobo, Bosco, Botno because, again, it's not something where there's like a top and bottom. But I can look at a rough sketch of this graph. What does an exponential function look like?
Exponential?
Going up.
Yeah, further up.
It goes like this. But what happens right here at 0? never touches it, which implies that there must be a horizontal asymptote at y equals 0.
Any other astronomic?
I only have 2 problems left, but if you need to go right now, you are welcome to do so. All right, 60. P of x equals 4 over x squared plus 1. So for vertical asymptotes, set the denominator equal to 0 and solve. So x squared plus 1 equals 0. X squared equals negative 1. Is there anywhere that x is going to be equal to 0? What happens when I take the square root of this?
Imaginary number.
It's an imaginary number. So there are none. Horizontal asymptote. I'm looking at the highest powered term, top and bottom. So I don't have any x's up here. I have an x squared down here. Where is it bigger?
The top.
What x is on the top? All I care about is the x's. Cover up all the other numbers.
The bottom.
So it's bigger on the bottom, which is Bobo, so y equals 0. $62. I'm gonna modify this one because, I'm gonna modify this one because I want us to see something that we didn't see in the other ones. J of x equals x squared minus 4 over 2x minus 4. So I set the denominator equal to 0. 2x minus 4 equals 0. 2x equals 4. So x equals 2. So I have a vertical asymptote at x equals 2. Now, horizontal asymptote, I'm looking at the highest powered term, so I'm going to cover up the number so you don't get distracted by them. I've got x squared over 2x. Which thing is bigger? The top. Bigger on top? No, there's not. There are none. So none. Now, you could potentially, if there was something on the bottom that you could factor, okay, like if we reversed this problem to be 2x minus 4 over x squared minus 4, okay, then what's going to happen is I have x squared minus 4 equals 0. X squared equals 4. So x equals plus or minus 2. So when I write my vertical asymptotes, I have 2. I have one at x equals negative 2, and I have one at x equals 2. Now the horizontal asymptote, what is it? It's bigger on the bottom, so y equals 0. Now, a lot of people don't like to write them as equations of lines, and you know what happens to people that don't do that? They get it wrong. Okay? Asymptotes are lines, so you need to write them as equations of lines. Any questions about that? Or anything from this section? I know it's been a lot. Alright, I don't think I gave y'all any problems yesterday, so let me go through here and find what I need to find. Alright, problems 1, 5, 7, 9, 11, 17, 21, 35, 39, 49, 51, 53, 55, and 61. So you need to do these in class today